You are once more welcome to this lectures room. I have a question here on calculus, which is differentiation question. The question says, differentiate using first principle. Y is equal to ax squared plus bx plus c. Now, we are asked to make use of first principle. Take note of that. Make sure you make use of that first principle. Don't do otherwise. Now, let's go ahead to solve the question now. Solution now. I'm going to write the question again. Y is equal to ax squared plus bx plus c. So, now at this level now, I can see that I'm having the value of my y in this side and I'm having the value of my x values in the right hand side. Now, I'm going to make effect of change in y-axis, and I will also make the same change to happen to the x-axis. So I'm going to have y plus dy. This dy means change in y-axis is equal to a into bracket x plus dx squared plus b into bracket x plus dx plus c. You can see that at every stage where I have my x, I try to make that addition of the x. Then look at this one. You can see that the square is outside. I put it in bracket and I put the square outside. The same thing here. There's x value here. So I also made the change of the x to be added to that value as well. Where there is no x value, I do not try to do any addition of x to it. So take note of that step very well. So you now continue by having y plus the y will be equal to, let's open up this bracket. For us to open up this bracket means x plus the x in bracket, x plus dx in bracket. If you expand this bracket, you are going to have a into bracket x squared plus 2x dx plus dx squared. Close the bracket. Plus, let's open the bracket. B times x is bx plus b times the x is b dx plus c. Now, at this stage now, you can now say, okay, let's try to use a to multiply through in this bracket here. We are going to have y plus dy will be equal to ax squared plus a times 2x dx. That's 2ax dx plus a times the x squared, a dx squared plus bx plus b dx plus c. That is the value that all these things transform into. At this level now that we have seen every value at the right hand side, that is the x axis value at the right x axis. Now we are not going to look at the value of the y alone by transferring this y to this right hand side. We are going to have the y will be equal to ax squared plus 2ax dx plus a dx squared plus bx plus b dx plus c minus y. You can see that this y is having a positive sign here. So when I transfer it to this right hand side, the sign will change to a negative value. Note, this y must not be left alone like this. We have to change the value to x. And don't forget that initially we have been given the value of y in our question, that y is equal to ax squared plus bx plus c. So let's those values represent y now. So let y be ax squared plus bx plus c. We are going to have the y will be equal to ax squared, as I have this there, plus 2ax dx plus a dx squared plus bx plus b dx plus c minus, what's the value of y? Open up the bracket for it. AS squared plus BS plus C. Close the bracket. Take note of this again. When you get to this level, you must open up the bracket for all these terms that are here. Since it is not a single term, you must open up the bracket for it, because if you do not open up the bracket for it, this particular negative signs will only affect the AS squared, which is going to have effect on the remaining solution to our question. So take note of that as well. So now opening all this bracket, now we are going to have the y will be equal to AS squared, I'm writing everything again, plus 2AX dx plus A dx squared plus bx plus b dx plus c minus all this minus times as squared minus as squared minus times bx minus bx minus times c minus c. You can see the effect of that negative value here. It has turned this positive signs to negative signs. Now, I'm now going to try to look at, you can see that there are some terms that looks alike there. So let's bring those terms together and let's see what is going to happen. Now, we are going to have the y will be equal to as squared minus as squared. I want to underline those ones that I have removed now. Then plus 2ax dx. There's no other value that looks like 2ax dx, so we leave that one like that. Then we have him, let's remove that one, plus a dx squared. Do you have any other value that looks like that? No. So we have removed this one as well. Plus bx, we have to remove this. Then we have minus bx here. Yes, minus bx, those are like terms. Minus bx, minus bx. So what do you have left? We have plus b dx. This is it. We do not have any other value that look alike like b dx. Then we have plus c. This is it. Minus c. And this is that. So you can see that I've underlined everything. I do that purposely because I do not want to make mistakes while trying to do this. Because if care is not taken, since we have many terms like this, you might mistakenly leave some behind, which is going to affect your next step you are going to take. So let's move on to solve this. So as squared, we subtract from as squared, so that makes that place to be equal to 0. We have this bs2 subtracted by bs, that's 0. C minus c, that's also 0. So the y will be equal to, what are we having left? 2ax dx, this 2ax dx plus a dx squared, that's the second one, plus b dx. I think you see that, yes. We have everything there now. So those are the remaining value that we are left behind it. At this stage now, we will be able to look at what is going to be the ratio of the y to the x and that of the right hand side. That is the ratio of the x to the left hand side compared to that of the right hand side. So let's look at that now. Now, why I have the y equal to 2ax dx here plus a dx plus b dx, I'm going to find the value of ratio of the y to the x. That is, divide through by the x. Divide through by the x. We are going to have the y now over the x. I've divided this side now, will be equal to 2ax dx over the x plus a dx squared over the x plus b dx over the x. So whereby this dx will go here like this. One of these dx will also go where this dx also go like this. So we are having behind on the y dx will be equal to 2ax plus a dx plus b plus b. Now, at this stage now, we can now look at it that, oh, we are almost through with solving of this question. So what we do at this stage now is that less the hence tends to 0. See, the y dx now, as the x tends to 0, you show that sign like that, you must make sure you show it, will be equal to, so wherever you see the x now, you put 0 there. That is the meaning of that. So that will be 2ax plus a multiplied by 0 plus b. Now, at this level, I think we have been able to get the answer. Now, the y dx will now be equal to 2ax. A times 0 is 0 plus b. That is the final answer for this question. Ordinarily, if you are to make use of formula method of solving differentiation, these steps will not be as long like this. 2, 3, 4 steps, you will have been through with this solution to this question. But the examiner really wants to know how you understand differentiation. That is why they will state it there that you should use the first principle. So that is how you are going to solve it. So try to study more of the question. Just more question yourself, solve it on your own, then you'll see that you'll be able to get it easily. Thank you and God bless.